Hello dear students. Today's lecture we are going to discuss about the Isaac physics. Next question is D5.2. Okay, here's the question. Consider a particle that is a particular antinode of the standing wave, which we call point A. So we have a standing wave and a particle that is the antinode, a certain particle that is antinode, and we call it at A. Fill in the table below to state how the motion of certain other particles will compare to this one. Okay, so this is question 5.2. So we have to compare with the next node, mean between this particle A, this point A, and the next node. Okay, so I made the diagram first, then I will explain. For example, we have the stationary wave, just like this one. This is the complete stationary wave. Here you can see that stationary wave, and next one is, this is the complete, we can draw the stationary wave pattern. Okay, two waves makes stationary wave. Okay, if they're traveling in the opposite direction. Okay, so here we have an antinode at this position. For example, this is antinode, and next between this point A and the next node is here. This is next node. Okay, so all the particles, the questions ask us to find the amplitude of all the particles from this antinode to the next coming node between point A and the next node. Okay, so all the particles are there. These are the particles that are between A and the next coming node. Okay, so remember that we have to find first the amplitude. Okay, so as we know that, we can see that amplitude of all other particles is smaller than A, because the A is the maximum displacement, mean that it has the maximum distance or displacement from the equilibrium line, but the other particles have the smaller displacement, have the smaller distance from this central line. So it means all the other particles except A, from this antinode to node, all other particles have smaller amplitude. You can see that smaller amplitude. So the correct option for A is amplitude compared to A. All other particles have the smaller amplitudes. So correct answer is smaller. So their amplitude, mean to extreme distance, is smaller. So you can see that distance of all other particles are smaller. Now for the part B, what is the phase relative to point A? So phase, we need to find the phase as well. Okay, so phase is actually, you can see that, as we know that the motion of A and all other particles till node between the A and N, all other particles are moving downward. Okay, all other particles are moving downward. So for example, I explain again. For example, we have this scenario again. We have a stationary wave. Okay, and in this stationary wave we can see that, so we have to find the phase. So phase, just I made the diagram again, then I will explain what is the phase. Here we have a particle A and then the node. Okay, so all the particles between this antinode and the node are these particles. You can see that these particles. Okay, now as we know that all the particles have direction downward, all these particles moving downward, because we know that this wave is coming downward, the motion is towards the downs. All the particles have same directions. So as we know that in the case of stationary wave, only the wave is going up and down, the particles going up and down. So it means, so their phase depends on the direction of motion, so all the particles from A to this point, after this one, all these particles are moving down, their motion is down. So it means they have the same phase, no phase difference. It means the particles have no phase difference. So the next option, the phase relative to A, is no phase difference, mean there is no phase difference between these two particles. So phase relative to A is 0, mean no phase difference. So no phase difference or phase difference is 0 degree. So all the particles have zero phase difference. Okay, so I can also explain from this simulation. For example, you can see that these particles are going up and down in the stationary wave. Okay, and all the particles, so when it goes up, okay, now you can see that these all particles from the top position to the next coming node, these are particles are moving downward, so they have the same phase. Okay, the phase difference is when these the other particle that separated by any node, that either separated by two node, one node, three node. Okay, so for example, if the particles are separated by nodes, then they have the phase difference. Okay, just like the particle that are next coming to next node, these particles have moving upward, so they have the phase difference of 180, you can see. But as compared to A to node, so all the particles are moving down, so they have no phase difference. So if they have no phase difference, so answer will be zero phase difference. Okay, so I hope it will work. Thank you.